All right, so I've been kind of inspired by a couple of folks on YouTube. Adam Savage's One Day Builds, especially with now that he's got time off from doing things with Mythbusters, he's doing stuff with Tested.com, and he's doing some one day builds, which are really fun. Matthias Wendell, who has a great YouTube channel where he makes all kinds of stuff out of wood. The guy's a real genius. And Jimmy DiResta, who does fantastic unnarrated videos. And a lot of them are time-lapse, but he shows you a lot of interesting techniques. So here's an idea that I had. Recently we got this bathroom redone, and the mirror that we had in there before won't fit because we lowered the light fixture. It's now mounted lower on the wall than it used to be. So the big mirror that we had in here before won't fit. Now, I have this old 16 by 20 inch oval mirror, but I don't have a frame for it. So I thought I'd try and do something kind of ridiculously fancy, which is I'm going to make a 13 segmented mirror frame to go around this out of the same mahogany that we made the floor out of. This is old tongue and groove flooring that I got from a friend. I have many hundreds of square feet of it, but when I cut the floor length, for the boards for the length of this floor that is in here in this bathroom, I had a lot of short pieces left over, so I thought I could use those and make myself an unusual 13 segmented mahogany frame for this oval mirror. So that's what I'm going to do here in 123D Design, and then out in the wood shop. It'll probably take me more than a day just because I've got too many other things going on. Usually you see me doing these videos out in my recording studio. This morning I'm in my living room because the recording studio is busy doing something else. I have it rendering another video, and I didn't want to record one video, rendering another, using the CAD program, so I'm using my laptop in the living room. So here, this is 123D Design, and so the thing that I've already done is I've already made a 16 by 20 inch, and if we oval here, and if we show this guy, then we can see it's 16 by 20. So that's already here. I'm going to hide this. And then I'm going to make, so now I need to make a 13 segmented frame. So to do that, we're going to draw a polygon. And I can't scale a polygon, so I'm going to have to extrude this first and then scale it, right? So I'm going to put it here, center at the origin. And then I want this to be an 8-inch radius and 13 segments. Now the thing I've got to be really careful to do here is that it really has to be right on 0, and it's not snapping, unfortunately. That's not a good thing. I really wish I could snap this. Let's try and just do it this way. 8 inches. Oh, stop. Now that I have a grid here, it'll snap. So we'll put the point at the top just so that I know that I'm, right on the grid on this. That way the segments will be the same left and right, and I've only got to make 6 on one side, 6 on the other, and then the 7th one, which is basically a keystone shaped, that's going to be even in the middle. So I've only got 7 different sets of measurements to do. You see I've got a spreadsheet over here on the right, and it's just a text document, but I've got tabs set up on that thing so that I can put all these measurements in. So 8 inches here, and then I'm going to make another one, same location, snap it here, and it is going to be 3 inches longer, so it's going to be 11 and 13. Bang. Okay. So now I have a 13 segmented ring. So if I select this, I can extrude it. But that won't very easily let me get the angles between all of these points. So what I really need to do here is I need to put a polyline between every set of vertices and then extrude all 13 pieces, and then I can measure those once I've, because I can't scale the sketch. You have to extrude them into a solid and then scale the solid, and then I can measure all the different angles. If I measured them right now, they'd all be the same because it's a 13-sided polygon. But I'm going to scale them so that they're 16 by 9, so that there's, you know, the one direction is 1.25 times longer than the other one, 20 over 16. Or 20 over 16 or 5 quarters, so 1.25. And the other direction is going to stay 1, so it's going to be this oval. All right. So in order to do that, we need to draw a whole bunch of lines, one between every matching vertices. So sketches, polylines. Unfortunately, I can do this. I want to edit this sketch, and it'll snap. Snap, snap, snap. Okay, now I got all the lines. Now I need to extrude every one of these, and I'm going to have to do every one of them separately because I want every one of them to be a separate polygon. If I just did them all at once, they would end up being one big 13-sided flat torus, and that's not what I need. I need these to be all individual segments so I can more easily measure the lengths of each side and the angles between them. So I'll see if I can do these actually as like every other one. So then I can do them now extrude just 0.75, just because that's what they're really going to be. That works. That's a little faster than doing 13 at once. I will have to do this as three different things. Extrude 0.75. Okay, and this one extrude 0.75. I learned something really recently kind of interesting, is that if you press the tab key here, then it's going to specify a degrees. So if you did 45 degrees, it's actually going to splay it out like that. That's really cool. So then you get this pyramid kind of shape. I don't want that. I just want 0. And also the default here says merge. It's going to merge these with the two adjacent to it. I don't want it to do that. I want it to be a new solid. So pick that, and then I have 13 different solids. All right, so at this point I am going to hide the sketches. So all I have here is the solids, but I still have this regular 13-sided polygon. Oops, these guys, I gotta undo one of these things. Okay, it decided it wanted to make those, merge them for me. 3, 4, 5, 6. Extrude 0.75, and yeah, it hit merge on new polygons. Okay, so make sure every one of these is a separate polygon, and do the same thing here. Back again, extrude 0.75, 0 degrees, new solid. Okay, so now, okay, back to hide sketches. All right, now I want to take these polygons, select them all, scale them non-uniform, and we'll pick the X direction 1.25. Okay, cool. Now just to double check, if I show the solids that I have in there, now you can see this matches up nicely, and so now I need to, let's rehide that mirror. And now I need it to be a little bit smaller because I need some overlap so I can mount the mirror behind, right? So I'm going to take this whole thing and I want it to be about 1/4 of an inch overlap. That means I need a 1/2 inch plus or minus. Let's say I want a 1/2 inch on each side. So I want a 1 inch, I'm going to shrink it by 1 inch. So I need a 1/2 inch. And I need to shrink the whole thing by 1 inch. It's 16 wide, so I need it to be 15/16 of what it currently is. Unfortunately, the scale won't let you actually put the math in. I brought up a calculator over here. Let's see, I've got a calculator on hotkey. And I want 15 over 16, and that is 0.9375. Okay, so select everything, scale it by a uniform 0.9375. It'll only take 3 digits. There's plenty. This is just so that I'm pretty close anyhow. Okay, double check, show the solids. Now you can see the overlap. That's going to be nice. Looks like that'll work good. All right, let's just hide him again just because I don't need to see that right now. Okay, so now on my table over here, I've got all the short and long sides for all of the different pieces. And these should be symmetric. Okay, so that's the first thing I want to check. Make sure I've done this right. The lengths and the angles of this piece and this piece, they better be the same. All right, so let's look here. Bring up the measuring tool, measure the short side and the long side. This will tell me the 2 different lengths. All right, so the short side is 3.645 and 5012, 3.645 and 5.012. Clear the measurements. Do the same thing over here. Better be the same. Yes, they are. Okay. Double check the angles. So I want the angle between this line and that line. I'm going to call that inner angle 1. Nah, I don't want to call that 1. I want to start from the middle and work my way around. So I actually want that to be the inner angle 1. And that is 107.1. And the inner angle 2 to be 95.7. Let's double check by clearing that. This angle and that angle, 107.1, and angle 2, 95.7. Okay. And then clear this, and let's do the outer angles just for consistency to make sure that everything's what we need it to be, 72.9 and 84.3. All right, so that's number 1. Let's close this. I'm going to put numbers on all these just so I know what they are. All right, so here we are, magic of time compression, numbering and measuring all the rest of the trapezoids. Really? Yep, it crashed. Hope I didn't lose all that work. If I did. Save early, save often. I didn't do it. I have a much earlier copy of this, but where did I save it? Nope. Start over. Okay, 15 minutes later, back where we were. All right. So now I have them numbered so that I can continue to fill in my spreadsheet. And let's just double check that I did it the same. Angle between. Yes, okay, good. Now I wish this box right here was stretchable a little bit, because I'd want to see the whole thing. It'd be a lot faster. All right, so 1 to 2. Now these angles better darn sight be the same. 101.2. Look at that. 101, 101.2. $78.98. And this one also better be 78.8. Now I can take all these measurements and go out to the wood shop. All right, so I decided I wasn't going to do the measure and measure and measure thing, because there's a lot of very specific angles on that. So I have a 3D printer, so I took the CAD models, extruded them. Actually, I crushed them down to about 0.7 millimeters, so they get just a couple of layers of plastic on here, and started printing some templates. And I've got the first 6 done. Pieces all end up looking like this. You can see I got the numbers on there, so I know which one's which. And there's number 1. So 1 through 6 are done. About to do 7. So here we go. Select file. I love this machine. This one is a really great 3D printer. You can hear in the background probably some talk on the computer. This is April the 8th, 2016, and SpaceX rocket is about to launch from Florida, so I'm watching the launch broadcasts. Yeah, wait till it warms up, and then here we go. Okay, now I just got to take the piece off the platform. I have to do this carefully because I don't want it to warp. I need a flat piece. There we go. Got it started and back. This nice little thin knife that came with the printer works really great. And there we go. Needs a little bit of cleanup. There's some flashing around the outside that I put on there deliberately. I don't know what that whole blob there is on the end. The printer did that kind of deliberately. It wasn't like something happened odd. It did that. I don't know why. So got me. Well, there we go. That's number 7. He's the keystone. This is actually, you saw me draw it. It was on the bottom, but it actually is the top. So you get a nice even top piece. Off to the shop.